Good afternoon, everyone. Myself, Professor Bharat Kak, working as an assistant professor at Palu University. Now, again, as a part of Continuum, the real-time implementation of IoT. Today, we have the Mr. T. Krishna from the HGate Technologies. Now, T. Krishna will give you some brief about the embedded system design, then how we convert the embedded system into IoT. Then he gives the introduction to Industry 4.0, the revolutions, and then Krishna will give some demonstration of the Texas instrumentation hardware which is available with us. So I would like to invite the T. Krishna from the SGate Technology. Krishna sir, can you please start your session? Yes.
Yes, sure. Thank you.
Yeah. Uh, your screen, you can share your screen
Yes.
first. Yeah. Okay. Now it is visible. Yes. You can continue.
Yeah. So, good morning. Good afternoon, everyone. So, we'll just have a brief webinar on embedded system and IoT and revolution of how the industry has developed a basic industry to a industry 4.0, which we are living now. Okay. So, before that, we need to understand what is embedded systems now first. Okay. Embedded systems is a machine, is a basic electronic machine. Okay, but what is the difference between a normal electronic machine and an embedded system is, let's compare with two different examples. You have few mechanical workshops, right? They are nothing but some electronic machines which works with power supply and does some operations which is already designed in such a way mechanically, right? But those type of machines cannot be controlled using a software or by hardware parts. Okay, which means that machine blindly does that particular functions how it is mechanically designed with. Okay, so you have some lathe machine, grinders, and so on in workshops, right? So these are all designed mechanically and hardware, like hardware parts which has to be gone in that particular flow, but we cannot change the operation in any way. Okay, except then changing the directions or changing the shapes or whatever it is, you can't change the operation. Okay, the process will be the same, but embedded systems are such type of electronic device where we can control it, like in a virtually, like it is in a software process. Through software you can control operation, like you can change the operation to one form to another form using software. That means embedded system is an electronic device which involves both hardware applications and the software application. That means the design of an embedded system is done both including in hardware parts and the software applications. Okay, so we'll just learn more about embedded systems. First, we'll have definition. So we just saw the definition. It is a combination of computer hardware and computer software. Okay, and embedded systems is programmed in such a way that it has to be done with a specific function or within a function within a larger system. For example, I just mentioned you telling it is a specific function or function within a larger system. So to understand this point, we'll just take two different embedded systems. Within embedded systems only, I'll just take two different examples to prove that these both embedded systems are task specific or specific function it will do individually. Let's suppose there is a washing machine this side and an ATM machine. You know ATM machine, right? Where you draw money, everything. So you have two embedded systems here. Okay. What is the process of my ATM machine? I insert a credit card or a debit card. I'll just draw the money using my ATM pin or something like that. And same way, coming to the washing machine has a functionality like once you put in your clothes, your different process has like some wash, rinse, spin, and you have different process, right? So ATM machine has this type of application. Washing machine has this type of application. Okay, both are embedded systems, by the way. Okay, my ATM machine cannot wash my clothes and give, and my washing machine cannot draw money. Am I right? It cannot. It both does its own individual work. That means every embedded system, not only these two. If you compare with any other embedded systems, also you will get the same thing. Every embedded system has its own specific functions to do. Okay, my ATM machine has its own functions to do. My washing machine has its own functions to do. And my air conditioner has its own functions to do. My TV has its own functions to do. My mobile phone has its own functions to do. These are all different applications of embedded system. And if you compare with any embedded system with any other embedded system, the functions will be completely variant. Okay. And we'll see few examples here. You can see it as industrial machines. We have agricultural department, they use embedded systems. We use it in automobiles, we use it in medical department, cameras, household appliances, airline departments, vending machines, toys, as well as your mobile phone itself is an embedded system. Okay, what all it is programmed to do, only those parts or those functions my mobile phone does. Apart from that, it cannot do anything. Like washing machine, if you go and ask me to cool my environment, it does not do, because it is programmed in such a way that it is actually it is a pre-programmed devices. So whatever is programmed inside the particular device, only those functions are set to be done, and rest all whatever you try to do, that cannot do, because it is blindly programmed in such a way that apart from this it cannot do anything else. Okay, right. So this is embedded systems, and you can see what all I can say it is. There is there are almost all departments where embedded systems are being used, and you can see house appliances, domestic appliances, hospitals, IT companies, and you can see, you saw it right in this applications where I mentioned it earlier: medical department, automobile department, travel department, ship airlines, everywhere it is there. Okay, so this is a brief introduction on embedded system. So we'll get to know more about embedded systems now. Okay, what is the importance of embedded systems? Why do we need embedded systems? Why is it so necessary? So why is it so necessary for embedded systems? First reason is, when we want to know some importance of a particular object or a device, we just compare it with the similar objects that are present in the market. Okay. Before that, let me just tell you one point. Embedded systems are pre-programmed and it does whatever is programmed inside. And the question is, how is that embedded system programmed? Using what it is programmed? So usually embedded systems are programmed either using a microcontroller or a microprocessor. Okay. So it's like it uses either of these processor or the controller to make that function smart or pre-programmed. So it is like, all right. So it is like either microcontroller will act as a brain of an embedded system, or microcontroller should act as a brain of an embedded system. That means for a computer, CPU controls all the peripherals, modules which are all connected to the CPU. Correct? For a human body, brain controls all the other organs, right? Brain controls all the other organs. So similarly, for an embedded systems, microcontroller or microprocessor is the brain of the complete system. Okay. Now, microcontroller. So I just mentioned you telling microcontroller. So what is a microcontroller? Microcontroller is nothing but a microcomputer. That means microcontroller is also called as a system on a complete chip. Complete system on a chip. Okay. And coming to the microprocessor, it is CPU on a chip. Both are a small chip. Okay. Microprocessor is a whole CPU on a single chip, but microcontroller is a whole system. That means whole computer on a single chip. That is why microcontrollers are called a microcomputers. Okay, whole computer is embedded in a single chip. That is why microcontroller is vastly used everywhere in electronic departments. Okay, and whatever application that uses electronics. Okay, right. So when we get to know about the advantages of embedded systems, we generally compare with normal computers with microcomputers. So we'll just see what are the advantages that we have. The first thing we just compare with microcomputer and a computer is, first thing we get into mind is size. So microcomputer is bearable within fingers and it's within a palm. Okay, but coming to the a computer, so you can see how big the microcomputer is, right? So you have CPU, monitor, keyboard, and mouse, and so on other things, which big, which builds up with a large space it needs. Okay, and just compare with a laptop also. Laptop, let's suppose compare with a laptop. So it has its own processor inside it, everything, but still the size matters, correct? And thing is, next thing you see is cost. So microcontroller, basic microcontroller, I think you will all be aware with it, and Arduino. Okay, Arduino is a basic microcontroller which can range a minimum from 300 rupees also, right? Your Arduino can cost minimum from 300 to 500 rupees. Okay, but comparing with the computer, you already know it will be around 30K or above that only. You don't get below 30K, right? The computer. So yes, cost comes with the major advantages with the size. And next thing you see is portability. Portability. So since the microcontroller carries within my palm, I can carry wherever I want. Okay. But computer, no. You have to shift the whole system and go wherever it is, and still the power supply may be the issue for it. Okay. You cannot make sure that wherever you go, you get the power supply on the way. Okay, but yes, there's one more advantages. Microcontroller can run with a power supply of 1.3 volts. Okay, it can run with 1.3 volts, where computers cannot run with it. Okay, computer needs high voltage to run it. And yes, you would have seen that computers, let's suppose there is a power issue happening, so still computer may run with the UPS, it may run hardly for 1 or 2 hours. More than that, it cannot run. So that means there is a high power supply that a computer requires to run. Okay. Yes, power supply was one among the advantages. And then real time performance. Now I need to develop a project using a computer one side, a microcontroller one side. And obviously you know what is the advantages. So once you start building a product using a microcontroller, you can take the complete product and place it wherever you want. Let's suppose I wanted to place this. I have designed a project in such a way that I need to monitor the temperature sensor, temperature reading, humidity reading, and other weather readings. Okay, so I've developed in such a way that I just kept it in a remote area like forest or somewhere. Okay, so I just keep getting notification every day, every 24 hours I keep getting some notifications. Okay, but what is the difficulty in building the same product using a computer? So you cannot carry the whole product with the computer. Power supply is very huge, performance will be difficult. You cannot run, or you cannot produce power supply 24 hours. But since microcontroller needs only 1.3 volts power supply, there is no big issue. You can provide power supply in such a way that it can run every time. Okay. So these are the few advantages of embedded systems over the computers. Okay. So this made microcomputer use in a vast range. Okay. So you can see I have written in the last line, it is power consumption, the advantages of power consumption, size limitation, reliability, and real-time performance. Okay, so these are the advantages. So we just see few characteristics of embedded systems. So coming to the characteristics of embedded systems, we'll just go one by one. All embedded systems are task specific. All embedded systems are task specific. Okay. Embedded systems are created to perform the task within the certain time frame. So we'll discuss about these two lines now. So task specific we have already discussed. I told you I gave an example of washing machine and ATM machine, right? Washing machine does its own functionality and ATM machine has its own functions to do. That means both embedded systems are task specific. That means it has its own individual tasks to be done or functions to be performed. Okay. So first one is it is a task specific. All embedded systems are task specific. And second one is embedded systems are created to perform the task within the certain time frame. So what does creating it within the certain time frame mean? Washing machine has three different process, and to complete the whole process it may take around maybe it's around 45 minutes or 1 hour, right? Usually all the washing machines take 45 minutes to 1 hour to complete the process, right? But if the device is said to be done within 45 minutes or within 1 hour, it has to be done within 1 hour or by 1 hour. The process should be completed by 1 hour or within 1 hour. Okay, so that is a protocol that every my embedded system has to follow. So whatever happens, the embedded system does not take more than 1 hour. I mean, I'm taking an example washing machine. Okay. So washing machine to complete its process, it cannot take more than 1 hour. Similarly, every embedded system has different time frames. Okay. So few may finish it off within 1 minute, or few may need only few seconds to complete the process. Few may take 1 or 2 hours to complete the particular process. Okay, so it depends upon individual embedded systems, and if the embedded system has a particular time frame, it has to be done by or within that particular time. Okay, simple. Okay, so these are one, and one more thing is they have minimal or no user interface. So what do you mean by minimal or no user interfaces? Few embedded systems functions are designed in such a way that it has to be have some it will need some input of human interference. So maybe like washing machine cannot start by its own. Yeah, as soon as I start owning my own machine, it has to be inputted with some clothes and water, everything. Only then the process starts. Okay. And same way, ATM machine also, it needs a debit card or a credit card to be inputted. Until then, it cannot start in process. So same way, uh, a few embedded systems like air conditioners and few other things, as soon as you on, it does its own work. You don't need to put some inputs onto it. Okay, few embedded systems may need minimum interference, few may need no interference at all. But you no need to stay with the embedded system continuously and look after it. It can do the functions by its own. Okay, but the thing is, few may need no interference, few may need a minimum interference. Okay, so it's like that. Okay. Give me a second, please. Right. Then I have some embedded systems are designed to react to the external stimuli and reacting accordingly. It's like few embedded systems need the it needs to depend upon the external parameters and function accordingly. Okay. Okay. It's like I just give an example like air conditioner only. Okay. So what does air conditioner do is as on you on the power supply for the air conditioner, what happens is it has an internal temperature inside it. Okay. It first monitors what is the room temperature. So you have already fixed it as the temperature that air conditioner has to maintain is around 25 degrees Celsius or 23 degrees Celsius. Okay. So when the air conditioner is already programmed in such a way that it has to maintain 25 degrees Celsius, first, as soon as I on the air conditioner, what happens is the temperature sensor analyzes what is the room temperature. Okay. The room temperature is, let's suppose it is summer and the room temperature is about 30 degrees. Okay. What my air conditioner has to do, it analyzes the room temperature as 30 or 32 degrees Celsius. So if the rule is to maintain it to 25 degrees Celsius. So it reduces the temperature by 6 or 7 units. Okay, so that it gets to the 25 degrees Celsius. Or let's suppose it is winter season, it is below 20 degrees Celsius and it has to increase the units to 5 or 6 degrees. So this embedded systems completely depends upon the external parameter, that is nothing but the room temperature. Okay. Same as this embedded system, there are many embedded systems which depends upon various external parameters. One of that is temperature. There are humidity, rain, it is solar, like light intensity. It depends on light intensity and varies the different applications and so on. Okay, there are many embedded systems which reacts or which has to depend upon the external parameter and do the functions accordingly. Okay, then I have embedded systems are built to achieve certain efficiency levels. This comes under time, certain time frames only. Okay, so it is like the embedded systems does not lose its efficiency until there is some fault in the embedded system. There may be software fault or hardware fault. Until there is any fault in embedded system, it cannot lose its efficiency. It is built in such a way that it provides a proper efficiency to the whole microcontroller. Okay, and then embedded systems cannot be changed or upgraded by the user because once the program is dumped into the microcontroller, so you do it through software, right? So whatever the particular hardware the system wants to do, I'll do it in a program manner. So that program will be dumped into the microcontroller hardware, and whatever is programmed inside the microcontroller, only these will be done. As we know, only this particular task will be done. So once after the microcontroller program is uploaded and a complete product is developed, okay, you cannot change the operation or you cannot upgrade the operation, because if you need to upgrade the operation, you have to remove the microcontroller, erase the program, put the new program. Okay, until you replace the program, your complete upgradability or change of operation cannot happen. Okay, since all embedded systems are task specific. Okay, so it cannot happen. So this this is safer in one side. Okay, once your code is all perfect and once it is uploaded, this can help us in the system being reliable and stable. Okay, since the operation cannot be changed or program cannot be replaced, you can tell it as the embedded systems as completely reliable and completely stable. So no interrupts or no interventions can disturb your process. Okay, all right. Then either microcontroller or microprocessor are used to design embedded systems. Okay, give me a second. Okay, either embedded systems either microcontroller or microprocessor are used to design the embedded system. Yes, because the hardware alone cannot perform all these tasks. There should be a software that controls the hardware part. Okay, embedded system is nothing but software which controls the hardware parts, right? Okay, so how does the software can control the hardware parts? Through microcontrollers or microprocessor. So these are the two main things that helps to design the complete embedded system. Okay, either microcontroller should be used to control, or either microprocessor will be used to control. Okay, embedded systems need connected peripherals to attach input and output devices. So every embedded systems will have peripherals. Peripherals may will be in different formats. Okay, few may have ADC peripherals, PWM peripherals, basic GPIO peripherals, timer peripherals, UART peripherals for communications. There are many embedded communication protocols available like UART, SPI, I2C, CAN, and so on. Okay, so these are all peripherals. Different microcontrollers will have different number of peripherals available. Okay, so these peripherals are used to add additional input or output that suits the application of the embedded system. Okay, like it needs to take some temperature value. Temperature value means we cannot get the digital value directly. The external parameters are all in analog in nature. So to convert analog to digital value, I need ADC peripheral. So my embedded systems require ADC peripheral within it. So so my embedded systems will have ADC peripheral added to it. So temperature sensor is the additional input or output device. Okay. So yes. So you will connect that particular input or output device through which I get analog values which will convert and give me digital value. So those digital value I'll use it for different applications within the embedded system. Okay, so for the air conditioner example that I'm telling here. Okay, so the temperature sensor gets the temperature value and it is basically an analog value. Since I have an internal ADC there, I'll get converted digital value, so using which I can do various applications or various changes in the process. Okay, right. Then the hardware of an embedded systems is used for security and performance. I told you it is a combination of hardware and software, right? So hardware is used for security and performance reasons, and software is used for changing the. It defines the feature of an embedded systems. So how do you define an embedded system? As when you come to security and performance, you tell the specification of hardware. Okay, when you when you come to tell the features of the embedded system, you mainly focus on the software. Software helps you to design the features of the embedded system. Hardware helps you to define the security and the performance of the system. Okay, simple. So these are all the characteristics of embedded system. I'll just give a glance on all the characteristics. First one is task specific. The microcontroller does not do any other operation as it is apart from what it is programmed to. Okay, and every embedded system has its own specific task to do. And second one is it has a time constraint. Okay, every embedded system is a time constraint. That means a particular embedded system is given particular time to complete the task. And that means that embedded system has to be completed the task within that certain time frame or by that particular side time frame. Let's suppose it is 10 minutes. It has to be completed by 10 minutes or within 10 minutes. Okay. They have minimal or no user interface. As I told you, few embedded systems are designed in such a way that there should be some human interference has to be done, minimum interference. Okay, but few embedded systems are designed in such a way that there is no human interference required. It will do its own functions by its own. There is no human interference required. Few embedded systems, but whatever embedded systems it may be, the human can no need to stay with the system and monitor 24 hours. Okay, whenever is required, then he can go do some inputs and come back. Okay, and then it depends upon external parameters to perform the operations. So external parameters, it may be temperature, humidity, fire sensors, smoke sensing devices, and a whole weather forecast or whatever it is. These are all comes under environmental parameters, which are called as external parameters. So few embedded systems are designed in such a way that it depends upon the external parameters and the process continues according to the inputs that come from the external parameters. Okay, and embedded systems are built to achieve certain efficiency level. Yes, different embedded systems have different efficiency percentage, and it maintains the efficiency until the fault happens either in the software part or the hardware part. Okay, until then it cannot lose or decrease the efficiency level at all. All right. Embedded systems cannot be changed or upgraded by the users, as it is a task specific, and once it is programmed into the hardware, you have to replace the program. Until then, you cannot upgrade or do. It's not like it is completely restricted to upgrade and all. That means if you start upgrading, the whole process changes, right? So that means if the complete embedded system is built, you cannot upgrade it. If you want to upgrade it, just remove the whole hardware, replace the complete program, then it can be upgraded. Okay, that time it becomes a new embedded system. It cannot remain an older embedded system. Okay, so that is the difference. So since it has this option or this features, it is told as it is a reliable function and a stable devices. Okay, then I have microcontrollers and microprocessor. So microcontroller or the microprocessor acts as a brain of an embedded system. That means these either of this are responsible for designing of an embedded system, or how that embedded system actually works. To define all the features of embedded systems, microcontroller or the microprocessor is completely responsible. Okay. Embedded systems need connected peripherals to attach input and output devices. Yes, if you want to connect any input devices or any output devices, you need peripherals that are connected to the controller or an embedded system, through which you can add your input devices if you want to add, or output devices if you want to add. Okay. Then the hardware of an embedded system defines security and performance. The software defines the features of the embedded systems. Okay, so these are the overall characteristics of embedded systems. So if it is everything fine, we can just move on to the complete next slide. So I hope you're getting all the points which I'm teaching here. Then coming to the microcontroller, we'll just give a little understand. We'll understand little about microcontroller so that we can go on with architecture of a basic microcontroller, and we'll understand the concept. Okay. So microcontroller. So what is a microcontroller? Microcontroller is a single chip microcomputer made with VLSI fabrication. So it is basically made using a VLSI fabrication. Okay. So as I told you, it is a single chip microcomputer. Okay, that means it is basically called an SoC. I hope you would have heard about SoC. SoC is nothing but system on a chip. Okay, it is a system on a chip. That means in a single chip, whole system is embedded inside. That means whole system is embedded inside the chip. Okay, that is called a microcontroller. Okay, that means since whole system is embedded inside the chip, it is called a microcomputer. Okay, the microcontroller also called an embedded controller. Okay, why is microcontroller called as an embedded controller? Because microcontroller is the one which it supports a circuit and are oftenly built into or are embedded into a whole device. Okay, because microcontroller is the one which controls the whole system once an embedded system is built. So microcontroller, including additional peripherals and modules, forms a complete embedded system. Right. So microcontroller controls the whole embedded systems. So microcontroller, also called as embedded controller, it controls the whole embedded system. Okay. Then coming to the different size of the microcontroller, microcontroller is available in different word lengths. Word lengths in the sense you would have been aware of many microcontrollers that you have worked on. Okay, so it generally comes with different bit microcontrollers. So coming to microcontrollers, there are 4-bit microcontrollers, 8-bit microcontroller, 16-bit microcontroller, and 32-bit microcontroller. So these are the microcontrollers which we work on. So depending upon what is your project and what is the size or performance of the project. Depending upon that, you can choose whether 4-bit is sufficient for your application, or 8-bit is sufficient for your application, or 16 or 32-bit. As of now, there are 4-bit, 8-bit, 16-bit, and 32-bit. There is soon to come, so 64-bit microcontroller to come at. Okay, so still it is in design process and testing process. So as of now, the maximum bit size the microcontrollers available here is 32-bit microcontrollers. Okay, and microcontroller is a low cost per unit. So we already discussed a basic microcontroller, that is Arduino. So Arduino ranges from 300 to 500 rupees. So you can see the cost also is very low. Okay, so there's a basic introduction of microcontrollers. Okay, so every microcontroller has an architecture in it. Okay, if you need to understand what is the specification, what are the features of a hardware that you have, a microcontroller hardware that you have, so we'll generally get to know using an architecture. So now, what is an architecture first of all? Okay, architecture is nothing but, I'll just give an example, a real-time example. Okay, okay, so you let's suppose you are a civil engineer. Okay, you are a civil engineer, so you wanted to build a house. Before building a house, what is required? Before building a house or a building, what is it necessary? You need a design plan of the building or a house. That is called as a blueprint of the house. Okay, you just design what is your length of your hall, what is the size, length, breadth, what is the size of your living room, what is the size of your dining room, kitchen, and all other rooms which you are going to add. Okay, so you'll have a perfect plan on a paper. That means designing a normal design. Okay, that is called as a blueprint. Okay, so you will design a blueprint. Using a blueprint, you will start building the house. Okay, then you will get to know what is the size of the hall should be, kitchen should be, dining should be, and so on. Okay, same way, when I need to build a microcontroller, I need a blueprint kind of thing here. So that blueprint is called as an architecture. So architecture is nothing but it tells you what all peripherals is included in the microcontroller. Let's suppose you want to create your own microcontroller, then create an architecture telling what is your size of your CPU, what is the performance of your CPU, what are the memory units that you are using, what are the additional peripherals that you are using. Okay, but whenever you design a basic microcontroller, you have to know what are the minimum peripherals that it has to have. Okay, here is a small diagram which every microcontroller will have. This is a basic architecture every microcontroller should have. So whichever microcontroller you see, that microcontroller's architecture will have all these blocks. Apart from that, it may have any additional more peripherals, blocks, or whatever it is. Okay, but for a basic microcontroller, these are the peripherals that has to be. All right. So in first the CPU. CPU will have, along with that, which drives the CPU. Which drives the CPU? Oscillators. Oscillators will have. Okay, and interrupt controllers. You have various controllers like external interrupt, internal interrupt, and so on. To control and perform in a systematic way, you have an interrupt controller in every microcontroller. And coming to memory unit, you have ROM, RAM as a basic one, and you have additional memories like flash memory, SRAM memory, and DRAM, and so on, like for different microcontrollers. That is their optional, but ROM and RAM should be present in every microcontroller. Okay, and you have timers available. Timers are the which makes our clock run synchronizedly. Okay, so it's like a heartbeat. For human being, how it is a heartbeat. For microcontroller, it is clock cycles. Clock cycles is basically in a square wave format. Okay. So if a particular peripheral is running in a synchronous way or no, that depends upon the clock cycles that we check. Using clock cycles, we'll get to know whether the device is working in a synchronous way or asynchronous way. All right. Then down you have bus control. So basically you have address bus and data bus. Okay, address bus is used to transfer address, okay, hexa values of address and so on. Data bus is to data communication, communicate data between two peripherals or two memory units, or CPU to peripherals, or CPU to memory units, and so on. So to control both address bus and the data bus, we have bus control unit, which controls the address bus and data bus. Okay, and input output ports. So input output ports are used for various applications like GPIO and other peripherals. If you want to add additional peripherals to the microcontroller, then you can use GPIOs, that are input output ports. If you are connecting an input device, connect to an input port. If you connect to an output device, connect to the output port. Okay, and serial ports. Serial ports are the communication peripherals. So among all the communication peripherals, you will have either of the one communication peripherals. So basic communication peripheral that most of the microcontrollers will have is UART. Okay, UART is nothing but universal asynchronous receiver transmitter. Okay, so that is one of the basic communication protocol that most of the microcontrollers have. Okay, so overall, these are the common blocks every microcontroller will have. So what is an architecture? Architecture is a plan of your microcontroller. So once you have a particular architecture, you can build your own microcontroller. Okay, simple. So there is a basic microcontroller consisting of, right? Then getting into IoT applications. So IoT applications is, what is an IoT? So till now we learned embedded systems and brief on embedded systems. Now we'll just have a small introduction on IoT and how is IoT, applications of IoT and so on. Okay. So IoT is nothing but Internet of Things. When I say Internet of Things, I'm mentioning it as things. That means Internet works on everything in this world. That means any non-living thing I can make it as an Internet enabled. Okay, any non-living thing in this world I can make it as a smart device. Even a stone, even my water bottle, even my chair, everything can be done as internet enabled. I mean, even my dustbin and water bottle can be done an IoT device. Okay, so how do you do it is, you need a internet connectivity for the particular object. Make sure you're providing an IP address to it. Once your IP address is provided, then yes, networking is possible through IP address, and internet is able to access to the particular object. So let's suppose I'm doing from a water bottle. Okay, from a water bottle, if I'm doing, so what I'll do is I will okay, what I'll do is, let's suppose I'll use some various sensor like water level sensor in it, so through which I'll get to know how much water is present in my water bottle. Okay, or dustbin. When I make a dustbin and IoT device, I can make in such a way, program in such a way that I'll get to know how much amount of dust is filled in the dustbin and when should I recycle it. So when should I drain it out and keep an empty one. So once it reaches 95% of dustbin, so it will indicate me telling that you need to drain out. Okay, drain out this stuff and make it empty. Okay, like that there are any non-living thing you can make it as smart devices. Okay, so how did my IoT evolve till now? So evolution of IoT, how did it happen? So under 2003, we got introduced with IoT. Okay, at 2003 we got introduced with IoT. There you can see the users were below 1 billion or 2 billion users were used. Okay, then go fast forward to 2008, we just saw around 8 to 9 billion users that used IoT. Then slowly came up with 2010, there we saw more than 10 billion people started using. It is around 12 to 13 billion users. And then in 2015 we just saw 20 to 25 billion users that used. And now around 2020 and 2021, we have more than 50 billion users you are using IoT devices, that is smart devices used. Okay. So this is the evolution how IoT grown from 2003 to 2020. All right. Then what are the applications of IoT? So applications of IoT are smart home. Smart home is my domestic applications, like I can make my Windows IoT devices. I can make my door IoT. I can make my light, fan, everything IoT. IoT. That means I can control all these things using a single phone. Using phone, I can open door, lock the door, open windows, close the windows, on my fan. If you want, I can also control the speed of the fan. I can control the lights, everything I can do. Sitting here, I can off my gas stove. I can off my oven, microwave oven in the kitchen. And same way, I can do it everything, making my smart home. I can make my complete home automated. So making my complete home automated, I can control all the devices in the home and wearable devices like your smart watches and so on. Okay. And smart city is like, there are few countries who is implemented with smart city. That means most of the things in the city are made IoT and can be controlled through a particular app using smartphones. Okay, smart grids, like what all widgets or gadgets that you use, right? And that things. And industrial internet. Industries also use IoT devices. Smart car is available. That is connected cars. Smart cars are used, and then you have connected health. So you have that. What is that? You have that pulse readings, right? So you have some digital sensors which calculates how much you have slept today, how much you have walked, how much you have done running, how much you have worked out. So that all will be calculated using the pulse sensor there, and the whole readings will be sent every 24 hours, right? The same way you have in field, you have smart retails, smart supply chains, and then you have farming also. Agriculture also uses smart IoT devices. Like, oh, you no need to go every time and water your farm, everything. So you will set timings and make it an IoT enable. So depending upon the weather as well as the timings, the water will be spilled evenly to the complete farm. Okay. It will make sure that there is no excess water stuck into that, so that the crops cannot be spoiled. All right. So these are the IoT applications. Then slowly we'll just move on to industrial revolution. How the industries have revolved from the basic industry level to the present industry level, how it is going on. Okay. And at industry 1.0, there was only steam engines and mechanical devices evolved. So through steam engines, you could use some that steam engine trains and so on, which used to run using that coal, charcoals and so on. Okay. Then evolving to industry 2.0, then came electricity, gas, crude oils and so on. So using which internal combustion engine came into existence. So through oils and crude oils, internal combustion engines started evolving, right? So thereon came some combustion vehicles like motor vehicles and so on, cars came into existence, right? And then after that, few more years later, then electronics and telecommunication computers came into existence. That was around 30 or 40 years ago, right? So these all came into existence. So there you can see from there on, ICs and controllers came into introduction. Okay. From then on, controllers came into introduction, like microcontrollers and so on. Okay. Then, as of now, that is Industry 4.0, we have internets and robotics. So, using this, we got to know IoT enabled devices. As I told you, there are more than 50 billion users that uses IoT device. More than 50 billion users are using IoT devices as of now. And robotics, there are many AI machines that has come up with. That is, it is like a human intelligence. AI is nothing but human intelligence, right? So what all human can do, the robot can do using AI applications. And this is how industry has evolved from 1.0 to 4.0. Okay. So coming to 4.0, it has a name trend of automations. The main terms that you can define industry 4.0 is automations. So you can automate anything here. Okay. The human has a capacity to automate anything in this world, and data exchange is possible with any object to any object. Okay, you can pick any non-living thing and exchange data between that particular thing. Correct. So data exchange has become very common nowadays. Okay, and you have cyber physical systems, including cyber physical systems is like you there is many disadvantages and advantages in cyber field, like so you can hack the devices. Same hacking is used for in advantageous ways also. And Internet of Things, as we discussed now, cloud computing, creating a smart factories and so on. Okay, this all came in Industry 4.0 revolution parts. Okay, during this Industry 4.0 revolution, these all took place. Okay, now we should just see. Okay, we just learned many things about microcontrollers, IoT, and so on, right? So now, if you want to develop an embedded application, so what are the things you have to keep it in mind? So, for example, you want to buy a new mobile phone. Okay, if you want to buy a new mobile phone, what are the things you will start? You will just see whether what is the CPU size, what is the performance, what is the camera, what is the screen size, so many things you just see, right? What is my RAM, what is my ROM, everything you see, right? Before you buy. Same way, if you want to choose, if you want to develop an embedded system, you have to choose which type of microcontroller is suitable. If you want to see which type of microcontroller is suitable, you have to check the specifications of microcontroller. So these are the few list of specifications that you have to check before you buy a microcontroller or an embedded system, develop an embedded system. You can see first is word length. You have 4 bit, 6 bit, sorry, 8 bit, 12 bit, and 16 bit and 32 bit, right? So these are the different word lengths that microcontrollers produces. Then you have speed. It provides you need to see what speed your microcontroller you need to use. Packaging, power consumption, on-chip RAM and ROM, on-chip peripherals if you want, upgradability, cost per unit, availability of tools. Once you select all these features, you cannot blindly pick up the microcontroller. You have to check whether the developing tools and the supporting softwares are all available for this microcontroller. If you choose a particular microcontroller which is all suitable for your application, and if you don't find the software and developing tools, what is the use? No, right? Nothing useful in this. So you have to see the particular tools and developing to software ideas are available. Okay, and support functions. You need to see every supporting function that suits your microcontroller. Okay. Yes. So now we'll have a small demo. So this much is my webinar. So we just discussed that we'll just have a small demo on any microcontroller. So as our company is working on Texas Instrument tools majorly, so I'll just brief out a basic introduction of a particular Texas Instrument tool, and out of it we'll just see one or two demo on it. Okay. So the hardware which you can see is TM4C123GH6PM. So the microcontroller name is TM4C123GH6PM, which is a series of a Texas made controller. Okay. So coming to the hardware part of it, you have a power supply pin here. You can see the power supply pin here, and a micro USB part where you can dump the program into it. There are two microcontrollers here which will act as an emulator, and below one is acting as a simulator. And other micro USB you have it here. This is to upload the program into the simulating microcontroller. But make sure whenever you dump the program, make sure you majorly use emulators, because whatever you program in emulator, you can replace the program or edit the program. or erase the program. But once you dump the program into the simulator microcontroller, whatever you do, even you break the microcontroller, you won't be able to replace the or rewrite the program into it. Once by mistake it is dumped into it, you cannot use the emulator microcontroller also. So it will be so difficult to use. So please do not use this micro USB. Always use the top micro USB to upload the program. Okay. This makes us use the emulator microcontroller. Then you have a reset switch here. Reset switch is used to reset the whole program. If you want to initialize the program from the beginning, just click on reset button. And below a reset button, you can see there is something called RGB user LED. So RGB LED is a red, green, blue LED. It is a single LED which provides all the three LEDs. Okay, using RGB LED, you can provide any combination of colors. Okay, and these are the 40 GPIO hardware pins available on the microcontroller. And below you have two user accessible switches. These are switch 1 and switch 2. If you have any application in such a way that using the switch you have to do different operations, you can use switch 1 and switch 2 here. Okay, so there's a brief introduction of hardware part. Then you have pin diagram. So using this pin diagram only, I'm going to program for this. So we just see LED, basic LED blinking and controlling the LED using a switch. Okay. So for that we need LED. We have to check which pins are allotted for LED. You can see here there is blue LED here. Pin number 40. You can see here pin number 40 is allotted for blue LED. Pin number is PF underscore 4. Okay, and then below that you have green LED, that is 39. Pin number is PF underscore 3. Okay, PF underscore 3 is PF is port F. Port F and pin number 2 and 3. Okay. Then you have red LED. Red LED you have PF underscore 1. PF underscore 1 is red LED. Port F is PF. So port F pin number 1 acts as red LED. Port F and port F pin number 2 acts as a blue LED. Port F pin number 3 acts as a green LED. Okay, these are the pin numbers. Alright, and switches also we'll discuss. Switches are represented as push 1 and push 2. You can see here push 1 is present here, that is pin number 31. PF underscore 4. Okay, and same way you have push 2 somewhere here. Yeah, push 2 is here. Pin number 17, that is PF underscore 0. Okay, so these are the pins we are working on here. Now I'll just close the PPT, open the software IDE which I'm working on. So I'll just show the two demos here. Okay, so I'll just stop the screen share.
I think your mic is mute. Can you please mic get mute? Voice is not audible. Yeah. Can you speak?
Right, I
Okay, yes,
think
sir.
I'm audible now.
Yes.
So this is my software IDE called as Energia IDE. Okay, so this IDE is a Texas Instruments IDE. So I'll just share you the download link for it. Okay, once after the webinar, I'll just share all the download link if you want to download the IDE. So here you have file options where you can create a new program and so on. So once after I create a new program, I'll get this IDE and you can start programming here. Okay. And in tools, you have to select which launchpad you're working on. So you can see here there is TM4C123 launchpad here, which my microcontroller works on 80 megahertz of frequency. Okay. So this board I'm selecting, and same way, since my microcontroller is already connected here, you can see my microcontroller is already connected to my laptop. So I'll get an option of COM here. If you're not connected, you won't get the COM option. Okay, COM port. So under COM port, I have selected COM4 here. Okay, so how do I check it? My demo examples are all present in the software itself. So once I select file And another example, I have basics. Under basics, I have blink. So if I click on it, I'll get a new window. So I just got a new window. I'll just share that window now. Okay. Right. I got this window. You can see here. This to program my red LED. That means I have programmed in such a. It is programmed in such a way that I keep blinking my red LED every 1 second. You can see here. Red LED high for 1000 milliseconds. 1000 milliseconds is 1 second. Same way, after 1 millisecond, 1000 milliseconds, red LED will become low. That means glow once, make it off for 1 second. Make it on for 1 second, make it off for 1 second. Okay. So this is the program. So what I'll do first, I'll compile. The tick mark I have, this is to compile the program. It checks any errors are present in the program. So you can see below part, it is compiling the sketch. You can see once done compiling, you can start uploading the code into the launchpad here. Okay. This symbol is used to dump the program into the launchpad. So I'll click on it. So it is uploading. Once it is uploading, I'll show you the output. So you can observe the video also meanwhile. So you can see here the microcontroller is blinking for every 1 second. I hope you are able to see the output. So the red LED is blinking for every 1 second. Okay. Now same way I'll also show the demo for switch controlling the LED using these two switches. Either of the two switches I'll control. Okay. Now I'll just go to the files. I'll go to the examples. Digital, I have button. So these are the buttons here. So I'll click on buttons. So I'll just stop the screen share and new tab is opened. So I'll just open that tab. Yeah, I think you're able to see this also. See, I've programmed for push to and the LED I have configured for green LED. Okay, I have configured for green LED. That means whenever I click on push to button, this button, my green LED will off and on. Okay, now you can see I'll just compile the program. Once the compilation is done, now I'll upload the program into it. Once the uploading is done, you can see green LED. Now, whenever I press this switch, my LED becomes off. See here. I hope you are able to see the output.
Yes, yes, got it.
Yeah. So this is how switch can control your LED. And same way, not only LED, there are various peripherals. Since it is a demo section, I just use GPIO pins, that is LED and switches. Okay, there are many peripherals like ADCs and so on. So like that, you can just use this controllers and demo videos. So this is all about this, and I just give a small introduction on my company also. So I'm working in Edgate Technologies. We give me a second. I'll just give a small brief on this. Once after that, I can end up the session. Yes. I work in Edgate Technology. So Edgate Technology is the official partners of Texas Instruments all over Asia. Okay, all over the continent. Edgate Technology is the only one traders which go on with Texas Instruments, and we provide various trainings like online trainings, off-campus training, on-campus training, offline trainings, and so on. And as of now, maybe from next month we have off-campus trainings available. As of now, we are just conducting online trainings available. Like we have many embedded system trainings, IoT internships available, which has both 10 days. I think 20 days is been starting from Monday onwards. So if you are interested on the internship, you can just contact with the marketing persons. We'll just give the contact. the meeting head can be able to help you out in these things. We'll just give all the information to the regard person, so he'll be helping out to join the internship if you are interested. Okay, and many trainings like AI trainings has also been started, so you can all enroll if you are interested on it. Okay, so I think yes, the company introduction and work which we do is already done. So we'll just show what all we work on. Okay. Yes, we work on embedded systems and real-time operating systems, DSP, that is discrete signal processing, and analog devices, IoT, robotics, and so on. Okay, these are the many fields which we work on. So if you are interested among these fields, you can just contact the marketing person, which you will get the information and the data later. Okay, thank you all. So if you have any
Uh,
questions, let me know.
yeah, okay. Thank you, Chaitanya sir. Now, I had one question from student side. Here we have discussed or we have seen the embedded based development boards. Okay, so is there any
Yes.
specific hardware board which available for IoT applications?
You have IoT application in the Texas Instruments only. Either you can use same board. This doesn't have a Wi-Fi capability.
Yeah.
For this, I have an additional Wi-Fi capability called CC3100. I can directly mount to it and use it for IoT application. If you are not comfortable with this, you have one more board called as CC3200, which is similar to the TIVA launchpad. There is a TM4C launchpad with an inbuilt Wi-Fi capability. You have many options of IoT applications in Texas Instruments also.
Okay, very good. And now again, I would like to thank on behalf of Tinkering Hub, Parul University as well. Okay, now for those who are the viewers, those who are attending this session, okay, I already share one link in the chat box, so everyone can please fill the feedback form as well as there is one short quiz is there, so we can also have the interested students and their contact detail as well as. Okay. And Chaitanya sir, on behalf of Parul University, I'm again very much thankful from the 8th grade as well.
You're
And
welcome, sir.
yes, and can you please send me the one? Can you please contact your marketing person as well? Whatever the hardware board which is available for IoT application in Texas Instrumentation, so you
Yes,
can
yes.
send me some
We
basic quotations. Yeah,
yes, I'll just text you on your WhatsApp number, so I'll just get the details of your marketing person.
no problem,
So
sir.
yes, sir.
Okay, because actually at Parul University we are going to develop the center of excellence in the IoT domain specifically.
Okay,
Okay,
okay.
so for that again we will have the need of yours expertise in the IoT domain as well as in other domain as well,
Sure,
and
sure,
this
sure.
hardware board is also required. Okay,
Sure,
so
sure.
for that we'll contact once we get the quotation and all these
All
things.
right, all right.
Okay.
We'll just give you the marketing manager's
No
number
problem, sir.
and
We'll go
contacts.
through the proper channel as well. Okay,
Yes, yes,
no
yes.
problem. We'll not directly contact you. You give us the whatever your email ID. We'll contact
Yes,
over
yes.
that, and then we'll come over there. No problem.
Yes, yes, because we are the technical person, we are
Yeah,
not
yeah.
aware about the marketing side. So we'll just give the contact of them
Not
so
an
they
issue.
can help you.
Thank again. I'm thankful for you. Okay, for
Yes,
giving
yes.
such a 1 hour of spending one
My
hour of
pleasure, sir.
time.
My
Yes,
pleasure.
yes. Okay. Thank you. Okay, so we'll end up the meeting here now.
Yes, yes, sure, sir. Thank you. Thank you all.
Okay, thank you.